Hi and welcome. I have with me Dr. Shalom Kelman from Baltimore. He introduced me to the Mishna, Ksubis Daf Tzaddik Gimel, when we met at the recent All Daf Baltimore Siyum. And the Mishnah has a complicated chalukah, a woman or a man who's paying out three separate ksubis to three different wives. And the Mishnah and the Gemara, they have a complicated chalukah. And Professor Robert Aumann actually wrote a theory or a paper on this. Dr. Kelman will explain this a little bit more, but there were still some questions on this, and Dr. Fred Gross introduced a simpler method of understanding this mathematical equation. There's a little bit above my pay grade, so I'm going to hand it over to Dr. Kelman to explain. But before he takes over, I just want to introduce Dr. Kelman. Dr. Kelman attended Yeshiva's Karen B'Yavne in 1973, followed by 3 years of intensive studies under Rav Hershel Schachter at YU. For 14 years, he had a weekly learning session with Rav Yehuda Kuperman of Meshech Chachma fame and other Svarim. Dr. Kelman has published in the areas of Gvulos Haaretz and Kedushas Yerushalayim, and regularly speaks at Torah institutions, including REITs and Yad HaRav Herzog in Yerushalayim. He has presented the Shabbos Daf Yomi at Shomer Yamuna in Baltimore since 2000. So it's my pleasure for Dr. Kelman to take us through this mathematical equation.
Thank you so much, Rabbi Shwed. It was a delight to meet you. And Shukayach for all you've done for the Daf Yomi. And it's my pleasure to share some exciting material with you on this upcoming Daf, which has been a mystery for almost 2,000 years. No one has really figured out how to truly understand the Mishnah. The Mishnah we're going to come across, like I said, is the Mishnah that begins on Daf Tzaddik Gimel Amud Aleph, and it says, Mi shehaya nasui shalosh nashim. A man is married to three women, umeis, and he dies, and they have different kesuvos. Different one has different claims. So there's a table here to help us simply understand the question of the Mishnah, the case of the Mishnah. You have on the top, you have the claims of each woman, we call them A1, A sub 2, A sub 3, and they each have a different claim on the estate. The wealthy one has a 300 first value, the second 200, and the lady 100. On this side, as you can see, you have the value of the estate. So in the value of the estate is 100. The chalukah, it seems very straightforward. You take 100, each one gets a third. That makes sense, but there's very little that you just divide among the three people who are claiming it. If you look at 300, that's also something of a svara, because it's proportional. Each one's claiming 300 to 200 to 100, and that would add up to 600, right? If add them all, if there was 600, everyone would get what they wanted. But you only have 300, so you have half. Everyone gets half of what they want, 150, 150. But the middle chalukah of 200, 75, 75, and 50 doesn't seem to follow any svara at all. And this is a mystery. And we'll see in the Gemara, has the Amoraim struggling, giving ukimtas, how can they understood? And in the end, the Gemara says at the end of Amud Aleph, Tanya, Brisa, Zu Mishnas Rav Nasan. This Mishnah is authored by Rav Nasan. Rebbe Omer, Ein ani roa devar of Rav Nasan, Elu, I don't understand or undersee it, Ela chokos b'shaveh. And in fact, that's how the Rishonim paskin. And the mystery has always been, well, what's the pshat of the Mishnah? And goes back, there's a famous riff who has much longer, the bigger riff than you'd expect on this little piece of Gemara. And he quotes Rav Haigon, who had an idea, maybe it was related to Shnai Mochs and Batalis, but never was able to implement that idea. How it was actually working in this case? And this question, I said, baffled Rishonim and Achronim, but the answer only came to light in our time, thanks to Professor Robert Aumann. Robert Aumann is famous in the world today. He won the Nobel Prize in Economic Sciences in 2005. There's a famous picture of him taking the prize with his big yarmulke. It was a Kiddush Hashem. And the area of his expertise for which he won the prize is called game theory. Game theory is a very sophisticated mathematical structure, and there are people who understand it. I'm not one of them. A lot of smart people don't understand it. It's a very, very, very difficult area. And the issue is, before I go ahead, this is the copy of this paper. And you all have, by the way, hopefully we'll have a PDFs available of the paper and another paper. He wrote 2 papers. This is the one he was written mainly for mathematical audience. It was in an economics journal. And as you see, it's game theoretic analysis of bankruptcy problem from the Talmud. He labeled this a bankruptcy problem because it's essentially the same kind of thing. You have an estate, you have to, and there's not enough money. So how do you divide what's available in the state equitably to all the shareholders? And notice it's dedicated to the memory. You have his son Shlomo, who was a Talmud Chacham, who was killed in action in Lebanon in 1982. And as he says in other sources, it was his son Shlomo who brought this to his attention. He said, Daddy, if you know game theory, maybe you can apply it to this Mishnah. And lo and behold, he was successful. He was able to do so. And the other paper I want to make a reference you'll have is a paper that was written more for non-mathematicians and to understand it on an intuitive level and for people in our world of Daf Yomi. So the second paper is also included. It was originally written in Hebrew, then translated into English, published in Bar Ilan. I should be available to you as well as a PDF. So what was some of Aumann's insights that allowed him to solve this problem? So the first thing he recognized was indeed, as Rav Hai had suggested, this division is based on the principle of Shnai Mochsim B'Talis. So we're going to learn a little bit about Shnai Mochsim today, from Beis Amud Aleph and Bava Metzia. We'll jump ahead a little bit. He also was able to restate Rashi's explanation of how that chalukah was done in a mathematical form, and we'll come to that in a few minutes. Another thing he recognized that one can expand the rule of Shnai Mochsim to not from 2 people to 3 or 4, as many as you need, using the same principle, as we'll explain in a few minutes. The main concept and the main idea of Shnai Mochsim B'Talis is that each claimant shares the same amount of loss as the other claimant. I'll give you an illustration in just a moment. But that's the chiddush, that's the thing we should all come away with. All the participants, every claimant, when compared to any other claimant, will have the same loss. And that is chalukas emes. That's the fairest way to a chalukah. Now, that's not always the case. In other types of chalukah, you have proportional. It's not necessarily everyone's going to have the same loss. It's not going to work out that way. But in chalukas emes, the goal of Shnai Mochsim is that everyone will receive the same amount of loss. Another thing Aumann was able to do was to suggest that once he was able to see the Mishnah and say, oh, this Mishnah fits the rules of what I expect from game theory, he was able to develop an algorithm to actually accomplish this. Now, how do you go about doing it? You have money, you have this stuff. So how do we do it in practical terms? He came up with an algorithm that allowed him to do it. All of this, though, the entire structure of what he created was based on his development of game theory. And he acknowledges this in his papers. He says, once I had game theory, I had the key to the garden. Now I was able to understand what's going on. And he's able to work back and figure out algorithms, etc. But how did the Tanoim know about it? Game theory is so sophisticated, it's very unlikely they had access to it. He struggles with this. He gives some theories how possibly intuitively they might have, etc. But it still remains a strong question. Now comes my chance to introduce Dr. Fred Gross. Dr. Gross himself was a noted mathematician. He had a PhD in number theory, but in addition, he had smicha from Torah V'das. His family came before the war, and he was a major, he loved learning and he loved mathematics. And he published extensively in his field, is well known in the field of math, but he also made many chidushim in the field of combining his mathematical knowledge with Torah insights. Most of this material, unfortunately, is still in manuscript form. And what I'm sharing with you today is also only in manuscript. I don't have a PDF I can share with you at this point. The family still wants to keep it until it's ready to be published, and then we'll be sending it out. But in addition to the things he says on this topic, he has on so many other topics. He always wanted to, in fact, write a textbook for high school students, showing them how the mathematics of Torah can help enhance their understanding of math and vice versa. So I was zochet to have a very nice relationship with Fred going back several years, and we discussed this topic many times. And he sent me a manuscript that he wrote with his son Aryeh that I used as the basis of today's presentation. What was Fred's big insight into this topic? He also applied the Bava Metzia division rule that I had previously noted. I didn't say that point that Aumann called it the contested garment, based on Stein-Mosen. And if all the chalukas have to be consistent with this contested garment. And Fred named it the BMD, the Bava Metzia division rule. And what he did was developed using the Bava Metzia rule, Stein-Mosen, using basic algebra and not requiring game theory. Thus, it was in the reach of Rav Nosson and all the other Tanoim who lived in the period of time of the Hellenistic time, the Roman, Greek periods, where basic algebra was available. Solving simultaneous equations, which we're going to do today, was accessible to them. They could do quadratic equations. They were very sophisticated in many areas of mathematics. So this is something that someone like Rav Nosson, who we know from the Gemara, was a math genius and astronomy. The Gemara has different quotations of Rav Nosson. We just had him recently in the Daf Yomi. Shibuda de Rav Nosson, A, O is B, and B, O, C, A, O, C, and so on. Rav Nosson was known for his mathematical prowess. And more than that, now that we have this algebraic approach, it's much more accessible to lay audiences like ourselves, and that's what I hope to share with you today. And by doing this, I hope to enhance our learning of the Daf Yomi this Friday. I should emphasize that both Professor Aumann and Dr. Gross's approaches yield the same results. There's no difference. All the numbers came out exactly the same. It's just how does one go about getting there that their approaches are different. And at the end, I will try to show how the two approaches actually intersect beautifully. So let's begin with the real thrust of today. What is the BMD, the Bava Metzia division rule? So Rashi, the classic Mishnah, is where Shnai Mochsen Betalis, one man says, it all belongs to me, so I found the Hefker, I grabbed it, it's mine. And the other gentleman says, no, we both picked it up at the same time, it belongs to both of us. So the first claimant says it's all mine, the second claimant says, no, half of it is mine, half of it is yours. What does Rashi explain over there? He says a simple explanation, which is, if I am the owner, if I'm the guy, the claimant A, who says it's all mine, so I say all of it is mine. Claimant B is saying, but part of it is yours, half of it is yours, I agree, and the other half we're arguing about. I say that's mine, and you say it's yours, but I disagree with you. So both agree, though, that half of it belongs to the claimant A. Therefore, he gets it without any problem. The contested part, the second half, is divided between the two of them. And that leads to a chalukah of one. He gets half of the half, the other one gets a half of the half, so the total he gets 3/4, one gets 1/4. That's how Rashi explains it. What Aumann was able to show mathematically was that the losses of the claimants are actually equal. And in order to explain that, let me just explain these few tiny equations, and we'll get into them more, understand it a little deeper. So another way of understanding the Bava Metzia rule is that the losses of the claimants must be shared. There's a loss to everyone. You divide it, and each one has the same degree of loss. To understand how you understand what a loss is, a shared loss, you look at what the total claims are. You subtract from it the estate, what's available, and that is the loss that they have to share between them. So the shared loss is divided between them equally. So when you end up with the claim, the C of the claim, minus the loss of the individual, that is the allotment. That's what that individual gets. So these are the concepts you're going to hear over and over again. A claim minus a loss equals an allotment. Now let's do our case, for example. A1 claims 1 talus. A sub 2 claims a half a talus. So based on our equation, the total claim minus the estate is the shared loss. The total claim is 1 plus a half is 1.5. What's the estate value? There's only 1 talus. What's the difference? A half. A half divided between them comes out to 1/4. A half times a half is a quarter. So each one has a loss of a quarter. That is a chalukas emes. How do we therefore divide it? So the allotment, what each one receives, is their claim, their individual claim minus their loss. So A1, A in the subscript A1, A refers to the allotment that we associate with A1, the big A1. He has a claim of 1. You subtract a quarter, that's his loss. You end up with 3/4. A2, the other contestant, he claimed only 1/2. And you subtract, that's his claim, 1/2. You subtract his loss, which is the same loss as the other fellow, a quarter, and you end up with a quarter. So this concept, I hope because clear as can be, we're going to come to it over and over, and through the Chazorah, I think I'm more comfortable with it. So again, another way of looking at this equation is just move things around, moving loss to the left and allotment to the right. The equivalent is to say a loss is a claim minus the allotment. So in this case, the loss of the two are equal. The loss is a claim minus the allotment. So loss of A1 is 1 minus 3/4, because his claim is 1, his allotment is 3/4, so his loss is a quarter. And A2, his claim was only a half to begin with, his allotment was a quarter, and therefore his loss is a quarter. The emphasis again is that the loss here in both, it has to be equal. Now, what are we going to do? How are we going to outline the approach that we're going to take now, as outlined by Dr. Gross? The general rule, again, the loss of claimants must be equal. We assume, and we're going to prove, a generalization of this rule, BMD rule, exists. In other words, we can do it not just for 2 individuals, we're going to expand it to 3 individuals. In all of these cases, we'll say that the individuals themselves, A1, A2, and A3, they have claims, C1, C2, and C3. And we always will put them in order such that E, which represents the entire estate, what's available, is greater or equal to C1, which is the higher claim, which is equal to or greater than the second claim, C2, which is going to be greater or equal to C3, the lowest claim. So in all these cases, we have to assume that they are put in a numerical order. Now, what we'll do is assume one of the claimants has received something. So let's assume A3, the one who's the lower value, received his allotment A sub 3. I hope it's clear. The uppercase A is the individual, the lowercase a is his allotment, and the subscript identifies who we're talking to. So the uppercase A3, he gets his allotment of the lowercase A3. That's the value, A3. Therefore, what's left? What's left is what A1 and A2. They share the remaining A1 plus A2 there, because A3 has been removed. So all you have left is A1 plus A2. And therefore, if the A1 and A2 have to split it up by the chalukas emes of the BMD rule, their losses must be equal. So claim 1 minus A1, that's the A1, that's what his claim minus his allotment is his loss, equals the claim of 2 minus his allotment, and that's his loss, and the losses have to be equal. So I hope this is clear, because this is the key of understanding everything that's coming afterwards. Now take note, you might always assume that the claim is whatever the guy asks for. So for example, in our case in the Mishna, the claim of the first of A1 should be 300, but that's not always the case, because the claim cannot be greater than what's available. In other words, even though he says his initial claim is C1, which in this case was 300, it can't be 300 if we assume A3 has taken part of the estate away. He's gotten his chalukah. So we always have to figure out what is actually the claim. And this is the chap you have to focus on. So again, the claim cannot be greater than what is available after A3 takes his allotment, leaving A1 and A2. So the way we denote this is say the claim of A1 is the lesser of either his actual claim or what's left after A3 gets what she takes, and leaves behind A1 plus A2. That would be left over. This is mathematically, this script is written as, denoted as the minimum of A1 plus A2, comma C1. Means what is the lower of these two values? It's either C1, which is his original claim, or it can be less than that because A3 has taken his part and therefore leaving behind A1 and A2, which is the lower part. The point again is that the claim can never exceed what's available. Now now we have that. Now we have the way to achieve what will give us the solution. How do we solve these equations? So let's assume once A3 receives her allotment, A3, we have one equation of known values, because we know C1 and C2, and we have unknowns. We don't know what the allotment is, A1 and A2. So we can write an equation. C1 minus A1 equals C2 minus A2. However, now let's assume we don't know that. We're going to make another equation based on another assumption. Let's assume, okay, and instead of saying A3 receives his or her allotment, let's start with A1. Let's say A1, who gets the highest claim, received his allotment first. We have a second equation because that's what's left over. In other words, C2 and C3 now have to contend. A2 and A3 have to contend with each other. So what are their chalukah? We say the losses have to be equal. So C2 minus A2, the loss, now the claim of C2 minus his allotment is his loss, is equal to the claim of A3 minus his allotment A3, which is his loss or her loss. So in other words, these two losses have to be equal. So we have two independent linear equations with three unknowns. We don't know the unknowns or the allotment, A1, A2, A3, but we do know what the claims are. So they have two equations. This is one equation, here's two equations, and we have a third equation. We know A1, A2, and A3, when you add up all the allotments, it has to be what the estate was. When we have three equations with three unknowns, we have the solution. We can solve now for A1, A2, and A3. So Fred was able to prove this algebraically, and it's not such a hard proof, you'll see. But the even more astounding was he can use the same method for 4 or 5 or 6 claimants because the number of equations just keeps growing. You have 4 equations and 4 unknowns, or 5 equations and 5 unknowns. And that's algebra that is accessible to people who understand algebra. Okay. Now, this is the meat of today's talk. And if all you can do to understand the next 4 slides, you'll understand the chalukah of the Mishnah, and then you'll really feel good about what you accomplished. Because this is something that Tanoim, Amorim could not understand. And now you're going to have the ability to understand it. So let's begin with the first case of the Mishnah. Remember, the Mishnah had, the first case was a value of 100. The estate's only worth 100. And the Mishnah said we divide everything equally. Everyone gets 100 divided by 3. Excuse me. Now, let's assume, I would say for each one, their claim initially was 300, 200, and 100, right? But the estate is only worth 100, right? So the most anyone can claim is 100. In other words, even though the claim C1 is 300, C2 is 200, but the actual claim is only 100 because that's all that's available. Now, A1 plus A2, but there's the allotment of A1 and A2 can never exceed 100. Why? Because A3 is taking a part. In other words, if you look at this A1, A2, and A3, that's each one's allotment, has to equal to 100. If A3 is getting something, then that's less than 100. So A1 and A2 has to be less than 100. So assume, like we said before, A3, his allotment goes first. Therefore, A1 and A2 each claim A1 and A2, what's ever left. Now, what's the minimum of the claim of A1? Is it A1 plus A2, or is his actual claim? Well, we just said before, it has to be less than his claim of 300 because A1 and A2 has to be less than 100. So the answer to this question has got to be it's A1 plus A2. It can't be C1, which would have been 300. It's got to be A1 and A2, which is less than 100. The same argument can be made with C2. C2's original claim was 200, and here we have a claim of either the minimum of A1 plus A2, which is less than 100, or C2, which is 200. So the answer is obviously A1, A2. So now let's use our equations. The loss of A1, defined by his claim minus his allotment, is the claim is A1 plus A2 minus his allotment, which is A1. So simple, it's A2. You subtract A1 minus A1, you're left with A2. The loss of A2, the same argument. The claim minus the allotment is the loss. His claim is A1 plus A2, as we pointed out. His claim is his allotment is, it should be a mistake, it's a typo, it should be A2. And therefore, his value should be A1. He should get, that was his loss, rather. His loss is A1. So by the rule of the BMD rule, it should be, therefore, the losses have to be equal. So A2 is equal to A1. We can do the same argument when A1 receives allotment first, and just compare A2 to A3, because even A3, as the claim was 100, but we know it can't be 100, it's got to be less than 100, because once we remove A1, A2 and A3 have to be less than 100. So the same argument applies to if A1 and A4 when A1 receives this allotment. So you have basically A1 equals A2 equals A3, which is like 3 times A1, which is the same as 100 divided by 3. So that's why everybody divides it equally, gets 100 divided by 3. That is the first case of the Mishnah. The second case is a little bit more complicated with an additional chap, but hopefully you'll be able to follow it relatively easily. The Mishnah's second case was the estate's worth 200. All right, so for E equals 200, what's the most A1 and A2 can claim is 200, right? That's all there is. So the claim of A1 can't be 300, and A2 can claim 200. And remember, A3 is only claiming 100. Now, since A1 plus A2 plus A3 has to be equal to 200, if you took away A3, A1 and A2 cannot exceed 200, because if A3 gets something, it diminishes 200. So A1 and A2 cannot be greater than 200. And similarly, A2 and A3 cannot exceed 200. If we took away A1 from this equation, then leaving A2 and A3, well, we know A1 has to be valued something, so it's going to diminish 200. So what's left, A2 and A3 cannot exceed 200. So let's begin the assessment like we did before. We look what happens with A3, as assume A3 received his allotment, and then we'll do the same thing, assume A1 received his allotment. So if A3 receives his allotment first, as before, using the same argument we had before, A1 equals A2. It's the same argument we had on the previous page. But if A1 receives A1 first, right? If A1 gets A1 first, then what's left? A2 and A3. So A2 and A3 have to share in A2 and A3. This A2 plus A3. So let's look at each one of the claims individually. What is A2's claim? A2's claim is, we said, the minimum between its actual claim, C2 200, or A2 and A3. Well, we just said A2 and A3 have to be less than 200 because A1 is there. If it takes this allotment, then it has to diminish 200. So we have to be, the A2 plus A3 has to be less than 200. So therefore, the minimum of this expression is not 200, it has to be less than that. A2 plus 3 has to be less. So therefore, the answer is A2 plus A3. So the claim of A2 is A plus A3. Its loss, therefore, is A2 plus A3, right, minus his allotment, A2. So therefore, gives you A3, right? A2 minus A2 and A3. So you have A3 left over. But with A3, it's not so pashut. A3's claim is, again, the same argument we said before. It's either the lesser, the minimum, of A2 plus A3, which is left after A1 takes this piece, so A2 plus A3 is left, A2 plus A3, or 100. That's his actual claim. At this point, we don't know. We have no way of, we can't use this argument we used earlier to determine what it is. So we have to leave it as unknown for now. So his loss is therefore the minimum of that expression minus what he received, A3. Now, since we said losses between the two claimants, once we moved A1, have A2 and A3, their losses have to be equal. So the loss of A2 is A3. The loss of A3 is this expression, and we make them equal. Losses are equal, so A3 equals that expression. The lesser of these, of either A2 plus 3 versus 100, minus A3, because that's what this expression was. We said the loss is this expression minus A3. So these this equation is what results. This simple manipulation, we add A3 to this side, add A3 to this side. So you have 2A3 equals what's the minimum of this expression. So here's now the Lamdasha cup. If we assume that the answer to this, what is this value, is A2 plus A3, let's assume the answer is not 100, but it's A2 plus A3. Then we have now the equation resolved to 2A3, this one over here, 2A3 equals A2 plus A3, which then comes out to, because remember, we're removing 100. We're saying the lesser is A2 plus A3. So that being the case, we go back to this equation, 2A3 equals A2 plus A3, which then comes out to, if you just subtract A3 from this side and from this side, you have A3 equals A2, A2 equals A3. All right, but we know from the first expression, if we assume that A3 receives his allotment first, we came to the conclusion A1 equals A2. And now we'll come to the conclusion A2 equals A3. So if A1 equals A2, so it comes out all the allotments are equal, like in the previous case. A1 will equal A2 equal 3, which is the same as 3 times A1, which is equals the estate is 200, or dividing it by 3, it comes out A1, and all the others will all be the same, will be 200 over 3, or 66.6. But if that's the case, then A2 plus A3 would be 133. And we said over here, right, which is A2 would be 133, which is greater than 100. In other words, in this expression, we said, what is the answer? What is the lesser of these two expressions? So we said, let's assume it's this one, A2 plus A3. But if we follow that, we end up with a contradiction, because then it comes out that A2 plus A3 is greater than 100. So that, therefore, can't be correct. Thus, our initial assumption that the minimum of these two would be A2 plus 3 is not valid. And therefore, we have to come to the conclusion it must be the other option, which is 100 is equal to 100. Therefore, now going back to this original equation, 2A3 equals 100. 100 there, 100 here. Or A3 equals 50. So once we now have come to the conclusion that A3 gets 50, so we know 200 equals A2 plus A3, and we know, therefore, once A3 gets his piece of 50, what's left is 150, A1 and A2, and since we said A1 equals A2, so each one gets 75. 2A equals 150, and we get 75. So this answers now the second case. We have the first one getting 50, the A3, the lesser getting 50, and then the remaining 150 has to be divided equally, because we came to the conclusion based on what we said, A1 equals A2, and therefore have now 75 for A1, A2, and 50 for A3. Let's look at a quick check to see if this, what I just suggested, fits what we're saying all along, that the total sums of the claims minus the estate equals the total loss, and then it has to be shared. So let's do a quick check. Again, assume A3 received the allotment of 50. So what is the claim of A1? We said it's 300, but it can't be. Why? Because what's left? Only it's a 200, right? Start with 200. If A3 gets 50, what's left? 150. So the maximum claim of A1 can be 150. Same thing, A2. It can't be 200, but it's only what's left, 150. Why? Because you can't claim more than what is available after A3 allotment. So therefore, let's do the numbers. The total claim is 100, 150, 150. It's 300, right? What is the estate's value after A3 takes his allotment? 150, not 200, right? Because we said A3 gets his 50. So what's left over is 150. So while do our equation, the total claim, which we said is 300, the 150 plus 50, minus the estate, which is not 200, but 150, because A3 got his estate, is equal to the shared loss. So 300 minus 150 is 150. That's the shared loss. and the shared loss has to be divided between them, which is 75 each. So therefore, individually, the claim of one or two, A1, A2 is 150, minus his loss is 75, minus 150 minus 75, and that explains why each one of them gets an allotment of 75. 75, 75, and A3 getting 50. So it all works out from both perspectives that we talked about. And now let's look at Mishnah 8 of the third Mishnah. A1 and A2, the Mishnah, the allotment, the estate available is 300. So again, let's use the same arguments. It's a little easier. A1 plus A2 cannot exceed 300, and A1 plus and A2 plus 3 cannot exceed 300. Again, for the same argument over and again, since the total is equal to 300, once we take away A3, then A3 has to diminish what's available. He's getting something, so A1 plus A2 cannot be 300. It has to be less than that. And the same thing with A3 takes, if A1 gets his allotment, then A2 and A3 has to be less than 300. So let's start where we usually start. A3 receives his allotment, A3 first. So let's look at the claims. What are the claims and what's the allotment to determine the loss? So A1's claim is the minimum of his claim of 300 or A1 plus A2. Well, that's clearly, the answer is A1 plus A2 because we already said that A1 plus A2 has to be less than 300 because A3 has diminished it. So this is an easy one to answer. So this expression is A1 plus A2, and therefore the loss is the claim, A1 plus A2, minus his assignment or allotment, A1, so he is equal to A2. So again, if A3 receives first, so the loss of A1 is A2, lowercase A2. If A2 now, in the same situation where A3 receives it first, what is the claim of A2 so we can determine the loss? So in this instance, we don't know. It's the minimum of A1 plus A2 versus 200. Well, this could be higher than 200. We don't know. So we'll just leave it as we don't know and calculate the loss is the minimum of this A1, A2 plus versus 200, which we don't know, minus his actual allotment, A2. So this expression is what we know about the loss of A2. This is expression what we know about the loss of A1. We equate them. So A2 from up here equals the expression from up here. Minimum A1 plus A2 of 200, right? Minus A2, because that's what we said. The loss is its claim minus its allotment. Or once we have this expression, we just move the A sub 2 to the other side. So add 2 plus A2 here and there. You have 2A sub 2 equals that expression. A1 plus A2, right, cannot be less than 200, right? Why? Since this means A3 is greater than 100. If we look at this again, if A2, A1 plus A2, can we say it cannot be less than 200, because if A3 gets his allotment, well, A3 can never get more than 100 because he's already claiming 100. So if A3 is only claiming 100, it can't get more than 100. So A1 and A2 it can't be less than 200, because otherwise A3 will be getting more than 100. I hope that's clear. I got momentarily lost myself. So again, A1 and A2, their claim together has to be greater than 200, because if the total claim is 300, I hate when this happens. This is the part I'm going to have to redo again. Okay, I'm going to start over from this line. Start from over again. So A1, so now we have decided that this is the equation of equality between the losses being equal. The A2 from over here, that was the claim, the loss of A1, and the loss of A2 is this expression we determined over here. It's minimum, this minus A2. We equate them, and therefore we can now move the A2 on this side to that side, and we have 2A2 equals this. Now we're trying to determine what is the minimum of this expression. So The argument is as follows. We can determine this. It cannot be less, this A1 plus A2 cannot be less than 200. We're trying to say that this has got to be, it can't be less than 200. Because if it was less than 200, then A3 is going to get more than 100. If this is less than 200, A1 plus A2, then A3 has got to be more than 100. But that can't be because he's only claiming 100. So therefore, we just proved that A1 and A2 can't be less than 200. So the answer then must be that in this expression, the minimum is 200. Because this has got to be more than 200. So this has got to be, the answer is 200. So if that's the case, then we have, back to our equation, 2A2 equals 200. And therefore, A2 is equal to 100. So now we know at least one allotment, based on this reasoning, is equal to a number that we know, 100. That is for assuming A3 received his allotment A3 first. What? Okay, so now, let's now look at from the other side. Assuming A1 receives his allotment first, and what's left is A2 and A3 to receive their share of A2 plus A3. Now, we know from the previous slide, we showed that A2 is equal to 100. So now we have A2 plus 3 is the same as 100 plus A3. Now, for A2, we're going to try to figure out the same we did before. What is the claim and what is the loss? For the claim of A2, it's the usual. It's the minimum of A2 plus A3, the allotment, what's left over after A1 received his allotment, versus his actual claim of 200. What is the lower value? Now, one thing we can plug in is now we know A2 is the same as 100, so this is now equivalent to 100 plus A sub 3, 200. Now, but we have some additional information to help us here. Since A sub 3, the allotment of 3, cannot exceed 100. Why? Because he only claims 100. So the minimum of these things, of 100 plus A3 versus 200, well, A3 has to be less than 100, right? So what's going to be the lower value? This or that? It's going to be 100 plus A3. So this now becomes the claim 100 plus A sub 3. So A2's claim is 100 plus A3. And now we can calculate the loss, because we just said the claim is 100 plus A3 minus his allotment. What we calculated earlier, A2 is equal to 100 for the previous slide. So now 100 plus A3 minus 100 comes out, loss is A3. So the loss of A2 is his claim minus his allotment, and it's equal to A3. Now, that's for A2. What about A3? He's the other remaining contender against A2 once A1 has received his a portion. For A3, the same issue. The minimum of 100 plus A3, because it's A2 plus A3, so A2 is 100, A2 plus A3 versus 100. What's the lower level? Well, it's got to be 100, since he only claims 100. So it can't be more than 100, so it can't be something 100 plus something, it has to be 100. So this now comes out to 100. So thus, A3's loss is his claim, which we said is 100, minus his allotment, which is A3. And now we can figure out the equation of equaling losses. We have the loss A3, which we calculate as 100 minus A3, that's here, equals the loss of A2, which was A3. So 100 minus A3 equals A3. A3 has to be 50, right? 100 minus 50 is 50. And therefore, if A3 is 50 and A2 is 100, then we know what's left. It's a total of 300, so A1 has to be 150. And thus we have figured out all the allotments of each of the individuals on each case of the Mishnah. Now, if you come away just with this information, you'll be able to say, I can explain each one of the chalukim in the Mishnah. And that was probably something that the Tanoim could do. Like I said, what we did today, this kind of reasoning through, what is the value for each of the situations. If we first take, what if A1 gets what he gets? And make the equations for A2 and A3. And then assume A3 gets what he gets. And now A1 versus A2. And do the equations for them. You'll arrive in every case at a very simple set of equations, and it's easy to solve like we just went through. And again, the principle again is that we assume one person gets what he does, and then we have to reassess, okay, what is the claim? Because the claim's going to change if someone takes away some from the estate. So you have to decide what is the actual claim, what he says or the lesser. If there's not enough left in the pot, his claim can't be as high. It's the most important yesod. And based on that, you have to have the two people are left. You calculate their losses. You say the claim minus his allotment of one equals the claim minus allotment of the other, and they have to be equal. And this will always be the case. And in all cases, and whether you're trying A2 versus A3 or A1 versus A2 or A1 versus A3, it doesn't make a difference. It always comes out equal. And this is enough to understand the Mishnah. And in practical terms, they didn't have to use all the they would do equations because they had numbers to play with. They had 300. The estate is 300. He's claiming this. He's claiming 100, 200, 300. They had numbers. So it made it easier for them to calculate. But the next level, from an algebraic standpoint, would be to substitute for numbers the actual symbols of C. And Fred did that. What I'm going to do next is not to frighten you, but just to show you how taking the algebraic level to another level will make it easier to actually program a calculator to do this for us. So what he did was here, he came up with these 9 scenarios, because each case is, you take the minimum of A1 and 2 and versus C1. What is it? What it can be all these possibilities. And the same thing, can be all these possibilities and these and these. And then you go through all the possible combinations, you end up with 9 combinations, and you can just make what's called the loss equations. We know the loss of this versus equal that, the loss of this equal that, and the loss equation, always point in every scenario, you're going to have 2 equations, and then you're going to have a third equation, which is the E equals A1 plus A2 plus A3, and all the way down, the same equation. And when you solve for these 3 equations on a algebraic method, you end up with these equations. Now, these equations are easily solved, by the way, if you use Mathematica or any kind of mathematical program. You don't have to use it by hand. You can do it quickly on the Mathematica. Once you have this, what he did was recognize that some of those cases, 1, 2, 3, 4 cases, were really special cases where the claim of 2 and 3 were equal. So he resolved with basically 5 cases, 5 scenarios. And in each scenario, by studying, he was able to determine that they all based on 5 different conditions of E. Depending on E, started with E being very low, very high, and so on, without going into the details. Once you have this, then you're able to write a nice program. So now that we have the ability to identify the E's, the estates, in different values of these inequalities, I was able to write a program which takes the opportunity to say, take in the value of E and look at what its value is in these different scenarios. If it's this one over here, then this is the equations for the allotments. If it's these and those and so on. And that's how this program was written. And once you have it, the beauty is you have a little calculator, and you can now play with this, and this will be available hopefully on the OLDOF website. You'll be able to download this. It's called a CDF. It's a type of PDF that you'll be able to play with. And as you see, the estate can be generated. So right now, I can move the estate, and you'll see below how the values of the various claimants change. So if at 100 until we get to a value of 150, the estate's 150, continues, and then you see it keeps changing, and then the values dynamically change. Now, to understand this better, it may be easier for us to look at a bar chart. I found that's a little easier for me to follow this. So let me do that now. And now you can see, if we go back to the beginning, when the estate is 100, so just like we expect, the division is equal, like the Mishnah says, everyone gets a third. And that stays that way as we add more, as more and more estate increases in value, we divide the estate equally among all three claimants. But when the value now reaches 150, what happens now is that C has received half of his claim, which was a claim of 100. Now she gets 50. So that's half the claim. So now we just simply divide the rest. As the estate gets more money, we divide that among the two remaining C1 and C2. And then when C2 gets 100, which is half of her claim, she claimed 100, 200. Now she's got 100 to half her claim. Then you see the chalukah now just gives money to, as the estate gets more money, we now divide it, only goes now to C1, to the claim of A1. And here's the interesting thing. When it reaches 350, however, then we start dividing it among both C1 and C2, the higher values, and they share, increasing as the value of the estate increases, they share that value equally up until about 450, and then C3 starts to increase and shares in the increased value of the estate. And as I emphasized earlier, in all of these chalukos, the claim minus the allotment, this is the loss, is always going to remain equal. If you keep C3 alone, remove that from the estate and just compare C1 and C2, their loss will be equal. If you just remove A1, like we said earlier, and get its chalukah, and just compare C2 to C3, their losses will be equal. And this is what you can dynamically see as we go further. And then when the estate has lots of money, everybody is increasing until they get their full requirement, which was 600, with everyone getting the 300, the 200, and the 100 equals 600, and everybody gets the full chalukah. Now, what's fascinating is when you look at this, again, this dynamic, I'll just repeat it one more time because I want to emphasize these points. Again, we start at the lowest value of 100. They all share together. Then when it reaches the half value of the claim of C3, which is 100, reaches 50, then we just add to the values that we divide the estate only between C1 and C2 until C2 reaches half. And then we just add to the C1 until it reaches 200, when they get to, and then they have to share again. The fascinating thing for me is this is the exact approach of the algorithm that Aumann described. Okay, now we can look at the Aumann algorithm. We'll see how it's identical to what we just saw with the bar charts. What he suggests, again, you order the creditors from lowest to highest, like we did, A1, A2, A3, A2, A1. You divide the estate equally among all the parties. That's what we're doing from the start. When you have the low values, when the whole estate is about 100, you divide each one equally, and you do that until the lowest creditor receives half of the claim, and that's what we saw in the bars. It went up to when 100 of the C3 got up to A3, got up to 50, and then it stopped moving. And now divide the estate equally among the remaining parties, right? Except the lowest creditor. You don't give him anything. You just give the other A1 and A2 until the next lowest creditor, was A2 in our case, receives half the claim. And that's exactly what happened. When he received his half of his claim, but his claim was 200, when he received 100, then his bar didn't move up anymore. And then we proceed until the next creditor reaches half of the original claim. And now you work in reverse. Start giving the highest claim more and more money until his loss, as was defined before, the difference between the claim and the award equals the loss of the next creditor. And that's what we'll see in a minute, how that works out. It's always going to be the same loss. And you're continuing this until you're finished. So this was exciting to see how using Aumann's approach is identical to using Dr. Gross's approach from a algebraic standpoint. Next slide shows another way of looking at this is simply like a diagram, a graph diagram. As you look again, you see as estate increases on the bottom here of the x-axis, it increases until it gets to 50. We add money into the system, and these all three are receiving, A1, A2, A3, receiving the same amounts until we get to 50. When it reaches 50, A3, the lowest one, no longer gets anything, but A1 and A2 continue to divide equally until A2 gets his 100 and doesn't get any more as the estate increases in value, because as the estate increases in value, over here, increases, we see that he doesn't get any extra, but rather we give all the money up to A1. But an astute observer will say, wait, if A1's getting all this money, how can the losses be the same? It seems that doesn't to be intuitively not right. How can the loss be the same if this one's keeping getting more and more money? The answer is how we defined a loss. And that'll be our final slide to tie it all together from the beginning. And once we get up to the 300 when it gets up to this value of about 350, then we see A1 and A2 continue to share until it gets to 450, and then all of them share at the same rate. To explain how it's possible that this can keep getting money by himself and yet maintain the same loss as A2, let's go one last slide. Remember, claim minus allotment equals loss. When the value of the estate was 300, remember, we assigned the claim based on what's available. Assume that A3 got his portion, was 50, so the estate, even though it's listed on the bars and so on, it's 300, but in reality, it's 250 is available. So A1, his claim was 300, but all that's available is 250, as we did earlier. So it's 250, and his allotment is 150, 100. That's his loss. A2, his maximum is 200. He can't ask for more than he asked, so it's 200 minus his allotment of 150. So the losses remain equal. When we go to the next level, when the estate is 325, remember we always have to take away the allotment of A3. That's because we're comparing A1 to A2. So A3 receives his allotment of 50. So what's the value of the estate? Is really 275. A1's claim was 300, but he can't ask for more than there is. So his claim is 275. He receives 175 based on the analysis and the algebra we did earlier, and therefore his loss is 100. A2 continues to have the same, doesn't change, as 100, so their loss stays the same. So therefore you see an opportunity here as A1 is getting more and more his allotment of 175, went from 150 to 175, yet because his claim continues to increase, the claim increases, this increases, and leaves the loss at 100, which is equal to the loss of A2. So this is how the A1 can get more money and yet remain the same loss as A2. When we get to a value of 350, which is beyond the Mishnah, the Mishnah was at 300, now we're at 350. Again, the same process, we take away A3, left out the value of the estate is 300. A1's claim was only 300. So that's 300. His allotment's 200, value, his loss is 100. And that's the same as A2. It hasn't changed. What if we go beyond that? And this is the last one. If we go beyond that, let's say, just to make the numbers easier, the estate now is up to 372. So again, comparing A1 to A2, A3 is removed. That leaves the 50 removed. That's, the estate is really 322. So A1, his claim is always 300, and the allotment based on the system is 211. His loss is 89. And that's the same. A2 is 200. His claim is 200, but he's now getting more money. Now he's starting to share. That's what we saw. The par C2's graph is starting to move up, and he gets 111, and therefore the loss remains the same. And this could be, you can look at this more with your calculator and play with it and get better insight into what's happening.
Okay, fine. So thank you very much, Dr. Kelman. For math fanatics, this is certainly going to be something which they'll find very, very intriguing. For the regular person, this is something that if they want to spend the time and go through it, they'll certainly be able to have a much better understanding of the Mishnah.